Okay, hello everyone. This is Antoine from Meta AI. I'm a co-director of the Fundamental AI Research Lab of Meta, and I'm very pleased today to join this data-centric AI day to talk a little bit about some of the very latest stuff we've been doing in the lab, and so I'm very excited to share them. So first of all, I wanted to start with the announcement and the recent news about our company. So Facebook, where our lab belongs, became Meta a few days ago on the road to a very exciting future towards metaverse and augmented reality. And if I mention this now, it's also because this is very relevant to the work we do in the FAIR lab, and I guess relevant to maybe some of project or ideas that people in this day are having. So I wanted to focus a little bit the presentation today about some of the latest project we've done who actually are laddering up to this future to give you a bit of a glimpse about how we're approaching that from a fundamental AI research standpoint. That's why, disclaimer, I made a lot of new slides today for this, so we are going to be in this journey together. So the main, this new meta, this new direction cohort contains a lot of direction, a lot of different exciting journey, a lot of questions as well that we're trying to work on. I would say one of the challenges and maybe of the opportunities as well, and of the big question mark that's outlined in this, is this idea about having new glasses with augmented reality, glasses like mine right now, but that should be able in the future, many years away, to replace the cell phone, the computer, the video conference, etc., etc. They could become, and that's our bet, they will become the next computing platform, or at least part of the computing platform that we use. And we announced a few months ago that we released the first set of these glasses, the Ray-Ban Stories. This is just a first step, but there will be many more. And why I'm talking about this today is that to unlock actually the capabilities of such glasses and such computing platform, we need a lot of AI breakthrough. Okay, a lot of things we need to unblock so that the AI can perceive the world around. The AI can actually be adapted to how user want to use the glasses, can be also relevant in the day-to-day scenarios, etc., etc., etc. And so this is a lot of ideas and a lot of potential, a lot of challenges for AI researcher, and I'm going to talk to you today about some of them. But before diving directly into what we do that connects to this long direction, I wanted to take a bit of a step back and tell you a bit more about who we are, FAIR, if you don't know. So FAIR is the Fundamental AI Research Lab of Meta. It's actually pretty old now, old, quote unquote. It was founded in 2013, so 8 years ago by Yann Lequin, Turing Award winner that most of you must know. And he was founded in the US, jointly in New York and Menlo Park. Today, FAIR is roughly grouping 450 people, all doing fundamental AI research. This means that this is research that is bottom-up. The ideas in the project are coming from the researcher. Research is done in an open and a collaborative way. In the people in the lab, we have scientists, engineers, and we also have a lot of students, and in particular PhD students. In the Paris office, where I'm right now to record this video, we have 90 people, including 30 PhD students that we have through the SIF program. And we have other sites all around the world, in London, in Tel Aviv, in Montreal, Seattle and Pittsburgh, and of course in Menlo Park and New York, where the adventure started. The mission of FAIR has been the same for the last 8 years, and it's still the same. It's advancing the state of the art of AI through open research and for the benefit of all, which means that the projects that come from our lab and that we work on are destined to improve and to push the frontier of AI. It does not mean that it means that we don't necessarily need to work on Facebook or Meta priorities, that we need to take on some of the product priorities. This is really fundamental research. And we have some values that are attached to the way we do research. And I will list some of them because they are really, really the core definition and the core pillar on how we approach research. The first one is openness. We publish and we open source everything that we do. Everything I'm going to talk about in the following slides is all published and all open source. We have a high value of responsibility on how we conduct research. It's coming to our ethics about the data we use, public data most of the time. Also how we do research by communicating, by sharing, by being submitted to peer reviews. Freedom, it's important. The research comes from the bottom, from the researcher, from the scientist, and not from top-down direction that says what we should do or not. Collaboration is very important. A lot of collaboration within the lab, a lot of collaboration within the company with other teams. It's particular now with the team building the AR or VR glasses and headset, more and more collaboration. But also a lot of collaboration externally, especially with universities. In France, we work with INRIA, we work with CNRS, we work with Sorbonne University, we work with Paris University, etc., etc., etc. And in the world, we have agreement with UCL in London, with CMU in Pittsburgh, etc., etc., etc. And actually, you will see in the project I'm going to present after that actually the way we do research in this collaboration is actually some of the key of how we actually unlocking the best results. Excellence, we want in the lab to push for really impactful results and not necessarily to do like many papers and stuff. It's more fewer paper, but very important, and scale in terms of data, the computation, but also the impact we want to have. So that's also an important one. So just a side note on the open source approach that we have. So if you go to our website, and I have the link at the end of my presentation, you will see a whole page with the tools for advancing AI that we put out there, which are all open source. And there are a lot of them, but maybe the most famous one that's at the top of the list is PyTorch, which is now the leading framework, completely open source to do AI research and development. That's also the same tool that we use for our project, our research project. That's also used internally by the product team for the AI that's developed internally. And we're very happy and proud about that. Fun fact, PyTorch started as an internship project in the lab, I would say 5 or 6 years ago, and now became something like super impactful. Last element on, I would say, our culture of research and the way we do research in this culture of openness, collaboration, and also reproducibility. You might be familiar with the website Papers with Code that's grouping a lot of the papers, the code, and now the data set, and they reached 5,000 data sets. I think it was last week. Paper with Code belongs to FAIR of Meta, and we work with them a lot in terms of also we can actually help the community to share, and to be reproducible. So they are an integrant part of our whole ecosystem. And they work with us, but they also have completely freedom to actually develop the agenda that they want for the site and for the mission. So on that, after this, I would say parenthesis, I think it's important to explain who we are and what we do and how we do it. Let me go back to the start of my presentation and this idea in terms of the breakthrough and the AI breakthrough that are needed to potentially unlock this new computing platform. And since today is about data-centric AI, I wanted to focus on 3 projects that are really connected to different ways of collecting, handling, and maybe using data for the future of AI, in particular in this world of AI and computing platform. The three projects will be Ego4D, Droidlet, and Reskin. Ego4D is a project about collecting and releasing a diverse and inclusive set of egocentric video, and I will talk a bit more about that. Droidlet is an interactive data collection platform to build and train agent through dialogue by talking to them. And Reskin, which is something very recent, is a whole new type of sensors, also open source, that allows to work with AI to be able to give them the sense of touch, which is going to be something that might actually unlock a lot of amazing possibilities. So let me go through all of them and tell you a bit some details about them. The first one is, and so Ego4D, and maybe the way to describe Ego4D would be to be able to teach AI to view the world through our eyes, right? If you look at the picture on the left, the big impact of Ego4D compared to the traditional data set and collection of computer vision, whereas for video or for image, is this viewpoint about this egocentric viewpoint. All the data from Ego4D is collected in an egocentric manner, which was by actually people who were wearing glasses that would actually capture. The glasses are not the one you would wear, they're actually bigger and a bit more prominent, but they are collecting this data where you see your hands, like I see mine right now, and this is actually the viewpoint that the AIs that will sit on AR glasses will have. And so it's very important right now to collect and to work on data that's really taking this viewpoint. So you have the website there. Ego4D was announced very recently, I think a couple of weeks ago, and with the paper and all the process and the data itself will be available for researchers by the end of November. So Ego4D, in a nutshell, and you can see in the video that's playing on the background, is really this idea about building AI that's going to see through your eyes, right? So really moving from having algorithm that can use images or videos that has been taken by someone who's taking their phone or taking a camera to take a picture, to places where you have a camera that are sitting at the level of your eyes and which they're going to see what you see, right? This was led by Kristen Groman, who's a researcher in our lab, sitting in the US. And what's very interesting with Ego4D, and maybe this example is actually nice, and then I will skip, is this idea about the fact of exactly, you see the difference when you're shooting a video, when you're looking like a grocery store, or when you're actually going a football game, if you're actually egocentric or if you're actually side by side, the view that you have, the view that the machine have is completely different. See, okay. So what was very important, and I think very new as well in the way Ego4D has been conceived, is that, as I said, FAIR is a very collaborative place. And so we worked and we designed the whole data set with collaboration with more than 20 universities around the world. Right, so this idea was like, it was not just us working with people also that to collect. We wanted to create a set that will reflect the vast diversity of people, of demographic, of use cases, of background, etc., that are around the world. So there is still work to be done, but there was a lot of thoughts that were put into this. And so as a result, the data set comes from 9 countries, and you can see the map on the top left. 9 countries from North America, South America, Europe, Africa, Asia, Middle East, 74 cities, and consist of hours and hours of videos that were taking this. This is multiple order of magnitudes bigger than anything that's been collected with this, and we expect will be a super big game changer for the community that will work with this kind of data. All throughout the process, we started with privacy and an ethical approach. which means that all the partners, so all the universities that were involved, they were responsible for developing their own privacy analytics policy, because some of those factors could vary between sites, between countries, between demographic. That's also the part of the game of working with multiple partners. But there were common guidelines that need to be followed, and you could find them on the Ego40 website. When I talk about diverse data, you have a big illustration there. This is the self-reported demographics, cultural residence, and age of the people who actually used the glasses to be able to collect the data. So you see, even if the majority of a big part of the people were between, I would say, 18 and 30, we have up to people like above like 60, 65, 70 years old wearing the glasses. So you might expect a lot of different use cases. And if you look at the distribution of male and female, you have roughly an equal repartition of genders. And in terms of countries, there is still work to be done, because I would say 44% self-report US, but still we have India, we have Rwanda, we have Italy, we have Japan, we have Singapore. So you will see when we release the data at the end of the month, if you check it out, that actually the diversity of the use cases and what people are doing is very, very breathtaking. In the back, you see a lot of the occupations of people in the data set. And once again, you have people, retired people, self-employed, of course, a lot of PhD students, but also photographer, musician, landscaper, etc. And what's very important for us when we're developing the AI that's going to be used, this data set to train, is that what are people doing when they're wearing these glasses? What are they using them for? Because then at the end, it will be also for the glasses, for the assistant that will be in the glasses, to be able to understand what people are doing, how they're doing it, why they're doing it. And so once again, here, you have a lot of variety of different things. I would say the main one, maybe it's a good representation of our daily lives. There's a lot of cleaning and laundry, 13% of the time, and a lot of cooking as well. So I say 1/4 of the time people are cleaning, doing laundry, or cooking. But you have a lot of other things, grocery shopping, clothes shopping, eating, doing yard work, etc. And if you look on the right, which is the other 31%, is super varied, right? And I think it makes also a lot of the actions, a lot of the daily action that we do or that people do around the world. It goes from fishing to hiking to actually working out to actually baking, camping, gardening, etc. So really, this Ego40 data set contains huge variety of activities taken by a huge variety of diverse people around the world. So I really wanted to make a showcase on Ego40, because I think that for us, and it's going to be a game changer. And also I wanted to really talk about it today because of the way it was collected, which was, I think, very new by working with this consortium of multiple universities to be able to collect the data set for computer vision with people that, with privacy analytics in mind, and a diverse set of community and locations. Moving on to, I would say, the second project I wanted to talk about. This project is called Droidlet. And Droidlet, it's also open source on GitHub. And here, the idea is more to be able to have interactive learning and interactive training of agents. So this idea about having humans and having agents or bots that are working side by side, and basically that you are able to actually train the agents, train the system by talking to them, by dialogue. And so as I subtitle here it today, it would be teaching AI to accomplish tasks by talking to them. So what is Droidlet? Droidlet is a modular, heterogeneous, and embodied agent architecture. What it means is that in Droidlet, we built and we implemented what we believe are the canonical components that an agent should have if you want it to be autonomous, or at least to be able to execute some task. So there is a controller that is able to manage the task and is able to actually decide on what are the next actions to be made. there is a perception module, the one that's actually taking some of the signal as input, for instance, from visual sensor, touching sensor, from speech, from sound, etc. So processing the information of the world and storing it in the third module, that's the memory module, that taking all the information from the perception, storing it in the memory, and connecting it with the information that the bot knows about the world, etc. And then the task, this is actually the kind of thing that the bot and the agent can do on the world, and that will have an impact on them. So when you have these four components that are all interconnected, this is, we believe, the kind of canonical architecture. But then what's pretty nice with Droidlet is that the way the architecture is done is that it's modular, in the sense that you could have, for instance, unscripted or rule-based controller if you want, and maybe a perception module that completely end-to-end deep learning centric and very complex. You could have a memory that's static memory, or that can actually be a complex memory. You can replace the controller from rule-based to something much more sophisticated using deeper reinforcement learning, etc., etc. So the idea of Droidlet is really to be able to make it modular and heterogeneous, so that you can work on some component without having to have the full architecture, touching the full architecture. So this is actually something that's really, really important, and I will give you some example about why it works. But in a nutshell, what Droidlet enables is that it gives researchers the ability to build agents that can do actually very complex tasks. And what's pretty nice, because we can switch, for instance, the perception module, you can actually use this perception module to work in the real world. So you give cameras, you put this on a robot, and the camera that can actually move and touch, etc. So real world perception. But you can replace the perception module with something that is just like getting data and input from a virtual environment like Minecraft. And actually, the first version of Droidlet was implemented in Minecraft with the goal of seeing, like, can I train a bot to accomplish tasks for me in Minecraft as a Minecraft companion? And Droidlet, you can test out different computer vision algorithms for your robot. So, you're switching. You can replace a way to deal with natural language instruction by another one. Maybe one is rule-based. The other one is actually more complex, more sophisticated. One is based on transformer, etc., etc., etc. Really, the idea is to come up with a design and modular architecture that's going to be generic enough, and in which you can plug and play different types of modules. For us, what's very interesting with teaching bot through dialogue is this idea about incremental learning. For instance, if you want to teach a bot to build a house in Minecraft, maybe teaching a bot first to build the wall, and then to tell the bot that a house needs to have 4 walls, and then you could actually teach a bot to build a roof, and then you would say, okay, a house is 4 walls and a roof. And you building like this, you could actually train robots to have more and more complex capabilities by building an incrementally. And doing this requires really an architecture like what Droidlet has, because you need the interplay between the controller, the perception, the task, and maybe most importantly, the memory. I give here an example about the dataset that we built for Droidlet in Minecraft. So we have created 2,500 house humans in Minecraft. You have the link here. And so then you can actually train a bot to say, build me a house, etc. That was actually a pretty fun dataset to build if you want my input on this. And so, of course, the end goal for us is this idea about to be able to, through Droidlet, to teach bots things in simulated and real world. And here you see the same kind of action on the left in Minecraft and on the right in a robot, where it's like point at, for instance, here it's pointing. This is the action of dancing, etc., etc. It's this action of actually grasping something, getting, so on the left, he was getting the stone. I can maybe play it again. No, I can't. He doesn't want me to. That's okay. But I think it's what's very interesting to look at this video that was a bit fast is that the action of pointing, the action of dancing, or the action of grasping, we train it with the bot through Droidlet on Minecraft. And then we take the code, we put it on the robot, switching the perception module from what will work in Minecraft to what will work in the robot, and it works very well on the robot as well. So that's actually the first step for us to be able to learning and to be able to generate this. The last project that is once again very recent, and I wanted to talk about, is about Reskin. And this idea is about trying to give the sense of touch to machine, and especially in particular to robots. In a future where physical and virtual world will be more intertwined, I believe that it's going to be super important for robots to be able to have this sense. And so here, the idea, and I will launch the video, you will see it looks like a bit of cooking, and you will wonder why I'm talking about this. It's a collaboration with Carnegie Mellon University in Pittsburgh. And so here the idea was to create some sensors that could actually give a very soft sense of touch. And we call them Reskin because this kind of mold, a kind of paste that has magnetic properties. So we call that magnetic sensing. And when you put it on the robot, it looks like some kind of a skin. It's actually you can manufacture it. It's not very hard. Actually, this is done right now with the right property. And then you can put it. It's low cost. It's compact. And what's funny is that the magnetic property, then you could put them on an actual sensor. And it works very well. And what's I think the most interesting with this project as well is that we have a self-supervised deep learning algorithm that is trained to recognize and to interpret the magnetic signal that come from this new skin. So you manufacture this new skin, you put it on the fingers of the robots, and then we have a deep learning algorithm that's able to interpret the signal so that the robot can feel. In action, if you look on this video to pick blueberries, which is something where you need to be very delicate. This is the same robot, but on the top you have Reskin, on the bottom you don't, and you will see that the robot is actually squashing the blueberries, whereas with Reskin is able to really be able to touch very smoothly and to pick up. Of course, because the goal is to pick up. So I went a bit fast on Reskin, but everything is on the website that I link. But what's very important for me to show is that we go beyond computer vision, we go beyond language, we even go to touch. And in FAIR, we are exploring all these different dimensions with the same approach, building in open source, working with universities, and trying to really advance the state of the art of AI. In closing, I really want to thank you for your attention. This was just a small extract of some of the projects we have cooking. There are many more cool stuff on the website, ai.facebook.com. And I also put the link of our GitHub repo where a lot of the code is there, github.com/Facebook research. Thank you so much.